D3. So the paragraph here is referred to as corpus. The second terminology is document. So each data line within the corpus is called the document here. So here the D1, D2 and D3 are the documents. The third is vocabulary. It is a collection of unique words in the entire corpus. If you see in the corpus, there are three sentences and the data lines are D1, D2 and D3. So the vocabulary that is formed are each word that are uniquely represented in the entire corpus. Please note there will be no repetitions of the word. For example, if you can see, the walk is being repeated here like 2 times. So it will be taken only 1 time in the vocabulary. So the first technique is the one-hot encoding. So this will convert the categorical data into the numerical representations. We are going to take the same example every time. So with these data lines, the vocabulary that we have generated after the stop word removal, so the number of words in vocabulary, the unique words in the vocabulary are 10 here. So the one hot encoding representation will give you according to the D1. D1 says the morning walk keeps fit. So you can say wherever these words are coming, it is saying true. It is giving 1 for that. So this way we are going to create a sparse matrix of all the documents which are present in the corpus. So if we take the example of the D1, morning walks keeps fit. So the total number of words in D1 are 4. So the vector representation of morning will be 1 and up to 10 it is 0. So whenever the any vector that will say 1 and all are zeros, it will be referring to the word morning here. So the sentence matrix representation of D1 will be given up as like this given here. And similarly for D2, D3 and D4, we can create a sparse matrix of vectors which will be representing each unique word in the corpus. So this technique has advantages. It is simple to implement and it also have many disadvantages like it forms sparse matrix. So there are very many unfilled elements in the matrix. So the memory is also wasted. Second disadvantage is out of vocabulary. So it cannot handle the new data. The third is not of fixed size. So like D1 was of size, there were only 4 words in the D1. So it was giving most of the elements was 0 in that. And the fourth is the semantic meaning is not captured. So the relationship is also lost. Another technique is bag of words, in which we are going to take the same example, and after the stop words, the vocab for each document is given here. So the total number of unique words in the vocabulary are 10, and we will also calculate the frequency of the unique words. For example, the morning is being repeated 2 times, walk is coming 3 times, and so on. So the bag of words representation will be given here as like that. In the document 1, we can see that the fit is coming 1 time, keeps is coming 1 time, morning is 1 time, and the walk is 4 times. If we see it vertically, the morning is coming 2 times here. So if you go to the morning, we can see it is coming 2 times. So before doing bag of words, it is recommended to lowercase the entire corpus because it will help in avoiding the repetition of the word. And the second thing to be noted is that the bag of words also have an option of binary bag of words, which represents that it will represent 1 if the word in the vocabulary is present or not. So here we can see the vector representation of the sentence. The document 1 it will be represented as like this. Wherever the word was coming, here it is marked as 1. Similarly for D2, D3 and D4. So this technique has also many advantages as well as disadvantages. So the advantage is that it is simple to implement and it also captures similarity between the words. But the disadvantages is it forms sparse matrix. It is the same disadvantage as we have seen in one hot encoding, the out of vocabulary disadvantage is also there, and another is that ordering of the words is completely changed. Now, another technique is TF-IDF, that stands for term frequency, inverse document frequency. Here, the term frequency means that more weightage is given to the rarely present word in the vocabulary. And the inverse document frequency refers to it captures the common words present in the document. So if we take the same example, the number of data lines that we have are 4, and after stop word removal, the total number of unique words that we are going to get is 10. So on calculating the TF, that is the term count in the document divided by the total number of words in the document. So for let us take the example of D1. Here we have 4 words. So for morning, the number of times it is occurring is 1, and here the 4 denotes the number of data lines that we have in the corpus. So this is the way we can calculate the TF. Similarly, for D2, D3, and D4, we are going to calculate the TF. The second step will be to calculate the IDF, which is the log of count of documents divided by the count of sentences containing the word. So if we see here, the N was 4 and the DF is the count of the sentences containing the word. In the table, you can see the keeps is coming 1 time. So calculating IDF, this will be the formula we will be using, and these values are calculated using the entire this formula only. Now the third step will be to calculate the TF IDF, that is a multiplication, or you can say the product of TF and IDF. So here you can see the TF of morning is 0.25 and IDF is 0.301. We just simply have to get the product of it. This is going to be the TF IDF of the word morning here. And the vector representation of D1 will be given up like this. Similarly, for D2, D3, and D4, we can get the vector representation. So the final interpretation of all this calculation was that the word appearing in many documents, like the word walk appearing 3 times. So if we go back to the slide, it has low IDF and therefore low TF IDF. If we see the walk, we are going to have low TF and low IDF. Therefore, the product is also going to be less. So the word appearing in only one document, like the body, delightful, this is going to have high IDF and therefore high TF IDF. So the purpose of this technique was to give high importance to the words that are rarely represented in the document. So the advantages are that the importance of each word is captured and the semantic information is also captured. But the disadvantages are, again, it in sparse matrix and it cannot handle the new data. So it will face the out of vocabulary problem. So we have seen some techniques that convert the vector to embedding. So based on the matrix that is being constructed, there are 2 types of matrices. One is sparse and another is dense matrix. For the sparse matrix, one hot encoding, bag of words, and TF IDF, they were creating sparse matrix. But what if we need dense matrix? For that, we will be seeing the technique word to vec. In this, there are 2 variations of neural network that it can use. One is continuous bag of words and another is skipgram. So if we take the same example for the word to vec, the first step will be text pre-processing that we have discussed yesterday. In that, we will be converting the entire corpus into lowercase and then we will remove the stop word. Second step will be to build a vocabulary to get all the unique words in the corpus. The third will be we have to decide a model type. So as I already said that word to vec has 2 architectures, skipgram and continuous bag of words. So if we want to predict the context from the target word, we will select scriptgram, and vice versa, we will be selecting the continuous bag of words. The fourth step will be to choose the window size, assuming that we will select window size as 2. That means we have to look 2 words before that word and after that word. And the fifth step is training the pair. Training pairs are created here. If we see the variation, 2 variations given, if we are going to take the scriptgram, then from the target, we are going to get the context. So for each word, we will create the pairs. Suppose the target is walk. So the context was within the window 2, it will be morning, keep, and fit. So the training pairs that are being created are walk, morning, walk, keeps, and walk, fit. Similarly, in the continuous bag of word, from the context, we are going to predict the target. So it is similar to scriptgram, just the logic is being reversed here. So the context is morning, keeps, fit, and the target is walk. So the training samples become morning, keeps, and fit. And from this context, we are going to predict the word walk. So our step 6 will be the neural network structure. So word2vec is a shallow neural network. So we will be defining the input layer, hidden layer, and the output layer. Step 7 will be learning word vectors. So during training, we have to adjust the model weight, and the word appearing in the similar context will get similar vectors. Our 8th step will be the output and the word embedding. So after training, we will get the dense vector for each word present in the corpus. So from here, we'll go to do the practical implementation. So in this section, we will demonstrate one-hot encoding. So for that, we will install the scikit-learn. This step is actually not needed in Colab. You can use it if it is already pre-installed, then you don't need to use it. But in case of Jupyter Notebook, you have to use this step. Then we are going to import the required libraries. Like from scikit-learn feature extraction.txt, we are going to import count vectorizer. And then for data frame creation, we will be importing pandas. Step 1 will be defining the document. I am taking the same example as we have discussed in the slide. So these are the data lines D1, D2, D3, and D4. So to create the one hot encoding vectorizer, we are going to initialize the vectorizer as count vectorizer, and the stop words that we are going to take are the English words. And here we are selecting binary equals to true. That simply means if the word is present in the corpus, it will give us 1, otherwise 0. And with the help of fit transform method, we are going to convert into the vectors. So now the step 3 is to create the data frame using pandas. It is similar as we have discussed yesterday. Now the output says we get all the vocabulary words. There are 10 words and the one hot encoding representation of each word, and the data line is given here as you can see in the output. In the second section, we will see the bag of words. For that, we are going to import the required libraries, that is again the count vectorizer and pandas. The step 1 is similar, defining the document, creating the count vectorizer as a step 2. If you note, the code for one hot encoding and bag of words is similar, but just the only difference here is the binary is by default false for that. If we make it true, then it will become one hot encoding. So if you see the output for this, vocabulary is coming same as for the one hot encoding. And if we convert it into data frame, the representation says like the bag of words representation here are given for the output here. So now if the word appears twice, the value will still be 1. But in case of bag of words, if the word appears twice, here the value will become twice. If you can see in the D3 for the word fit, we are getting the frequency 2 for the word fit. In section 3, we will see TF, IDF. So this step is same as above. We are going to import the libraries and then define the document. We are going to create the TF, IDF vectorizer and initializing it using the stopwords of English. So if you want the raw TF, IDF without normalization, we have to add a parameter and that will be norm equals to none. And step 3, we are going to convert it into a data frame. So this will give an output. You can see all the vocabularies here, and this is the TF, IDF representation of the entire corpus. So if you want to see the IDF values separately, you can just run this cell whenever you are doing the hands-on. So for each and every value, we can calculate the IDF here. In this section 4, we will discuss the word2vec. So it has two architecture, scriptgram and continuous bag of words. For that, we are going to install the library gensim. So it is a Python library for NLP. So it is mainly used for topic modeling and word embeddings. So it helps in convert the text data into the numerical representation, which is understandable by machine. The step 1 is to define a paragraph. You can also import any data, like you can import any CSV file. And the step 2 will be pre-processing. We are going to convert into lowercase and remove punctuations. These steps is same as we have discussed yesterday in the tutorial. If you see in the output, we are getting the clean text. All the words are converted into lowercase and all the punctuations are being removed here. The third step will be tokenization. With the help of NLTK tokenized library, we are going to get all the words from the corpus. As you can see in the output, each and every word has been extracted as tokens here. In the step 4, we are going to create a list of sentences where each sentence itself is a word of list of words. And the step 5 is to train the word2vec. First, we will try with scriptgram model. For that, from the gensim.models, we are going to import the word2vec. Here it is used to convert the words into numerical vectors. And then we are going to train the scriptgram model. For that, these are the parameters which we can pass it in the word2vec method. The first is the sentences. So these are the input training data, a list of tokenized sentences. Example like morning, walk, keeps, fit. So this will be passed as sentences here. You can see in the above cells, we have already created the list of sentences. That is what we are passing up here. We are selecting the vector size as 50. So this is the dimensionality of the word vectors. So each word will be represented with a vector with 50 numbers. So now we are taking the window size as 3. That is the context window size. So the model will look as the three words before and the three words after the target word. And then we are taking the minimum count as 1, which represents the word appearing less than this count will be ignored. And here SG means the skip gram. If we are selecting it as 1, that means we are going to train the skip gram model. And if we do it 0, then we are going to train the continuous bag of words model. The next cell is same as above. Here we are selecting the skip gram SG equals to 0 to demonstrate continuous bag of word. To find the similar words, we are going to find a word, how the word economy is similar to other words. So based on the word embeddings that we have learned in the word2vec skipgram model, the output says that word economy and need are related this many times. Similarly, for all the other words, using the skipgram model and the continuous bag of words model, we can find the relation between the two words. We can also do cosine similarity between the two words. So this is used to calculate the similarity between the word economy and India. So passing the two words in the function uh, similarity, we can calculate the semantic relationship between these two words. So after running the code, we have observed that in skipgram, it works better for the rare words and it captures the semantic relation slightly better than the continuous bag of words. Whereas the continuous bag of words, it is faster in training and it is good for frequent words. So the reason behind it is the difference that comes from how this model learns the word context relationship. So in the continuous bag of words, it will predict the target word from the surrounding context word. And in the skip gram, it will predict the surrounding context word from the target word. So because the learning direction is different, their behavior also changes. So if I try to summarize the entire two architectures in one line, so the skip gram focuses on learning context relationship for each word, which help rare words and the semantic understanding, while the continuous bag of words averages context information, making it computationally faster and effective for frequent words. In this step, this is an optional step. You can do it to visualize the word embeddings. I am making a 2D plot for it. For that, I am importing the matplotlib library for plotting the graphs and visualization. And I am using the PCA from scikit-learn. It is used to reduce the high dimensional data into lower dimensions. As we have seen, it was 50 dimension vector size. So I'm converting it into the 2-dimension vector size. So I hope this is clear to you. If you have any doubts, please post it in the chat box. If any one of you are coding parallelly with me, you can post your doubts in the chat. I will wait for 5 minutes. And then we will see an end-to-end spam classification using the NLP pipeline, which will give you a basic understanding of the yesterday tutorial and today's tutorial. So if no one is having doubt, we will proceed further. We will see the end-to-end spam classification. In this, we are going to do the text pre-processing using the NLTK library. In this, we will see tokenization, stop-word removal, stemming, as well as lemmatization, which is an optional. You can use either of them. The second we will see is the text embedding. We have separate sections for all of them. We are going to compare the result from it. And we are going to do the classification using the logistic regression. For that, you can use other classification models also, which are mentioned here. So these are the basic steps you have to follow for any type of application. First is the text pre-processing. Second will be the text embedding. And third will be training a classification model. So we are going to train and split the data as the training data and the test data. Then we are going to select the model. We are going to train the model and then evaluate the final result. So first step will be to installing the all the libraries like NLTK, scikit-learn, gensim, matplotlib. So NLTK is required for text pre-processing and NLP tasks. Scikit-learn will be the machine learning library here, and gensim is the advanced text representation and topic modeling library. Step 1 is to import all the libraries. So I'll be discussing one by one. We need pandas for handling dataset. We will be needing NumPy for the numerical operation and array handling. We need RE, that is regular expressions for text cleaning, NLTK for NLP task, and matplotlib for the plotting the graphs and visualization. We are going to import the library like stopwords for the stopword list from NLTK to remove the common words. We are also going to import word tokenize to split the text into individual words. Then the Porter stemmer and the word net lemmatizer for stemming and lemmatization. From scikit-learn model selection, we will be importing the train test split and cross validation score. So this is for splitting the data set and performing cross validation. We are going to import two classification libraries here, that is a logistic regression classifier and the knife-based classifier. We are going to download the libraries like classification report and accuracy score for the evaluation of the metrics. And from scikit-learn feature extraction, we are going to import the count vectorizer and TF-IDF vectorizer. And from gensim models, we are going to import the word2vec for creating the word embeddings. The step 2 is to download all the NLTK resources like the punctab, stopwords, and the wordnet. These are the support libraries that will be required when we are proceeding further in the cells. So here we are going to download the real SMS spam dataset. We can download the dataset from UCI machine learning repository. So if you see in the line number 5, this wget, it is a command line tool used to download the files from the internet as a compressed zip file. The syntax will be wget, and then we are going to pass the URL of the publicly available dataset. We are going to extract and unzip the downloaded zip file so that the dataset can be accessed using the unzip command here. Our fourth step is to load the dataset. So we are going to load this dataset and then convert into the This URL can be, yes, it can be from anywhere, but just make sure it is publicly available. Okay, the step 4 will be to load the data set. So here we are loading the data set and then we are converting into pandas data frame. If we see this word separator, so this specifies that the file uses a tab separated file, and the names here with the label and text assigns the column names to the dataset. So if we convert the text labels into numerical values for machine learning models, we are taking ham as 0 and spam as 1. So creating a new label, we are going to map is ham as 0 and spam equals to 1, and the output will look like this. So the shape of the data set is like it has around 5,000 plus rows and 2 columns here labeled as label and the text. Our step 5 will be to perform the text pre-processing. In this, we are going to clean, tokenize and perform stopword removal, stemming and lemmatization. This step is same as we have discussed yesterday. We are going to initialize the Porter stemmer object and the wordnet lemmatizer. And inside a function, we are going to convert all the text to the lowercase. We are removing all the punctuations, numbers, and special symbols, and then tokenizing each text into individual words. This function will return processed words back into the clean sentences, as you can see in the output here. So we are getting a new column named as clean text after applying the pre-processing. So now the step 5, before proceeding for classification, we have to split the data set into the training and the testing. So for that, here we are using the function train test split. In this, the parameters that we are passing here is the feature data. The first parameter, the clean text that is we are passing, that is the feature data. The second parameter are the labels, that is the target variable. The test size is 0.3. That means the test data is the 30% and the training data is automatically going to be the 70%. And the random state is 42. This is to fix the randomness every time going to run the model. So in section 1, we will discuss the one-hot encoding. So for this, we are going to create a count vectorizer object for one-hot encoding. Uh, Keeping binary equals to true, that means we are only going to record whether the word appears or not. So converting this clean text into one-hot encoding matrix, fit transform learns the vocabulary and transform the text into vectors. So we will be initializing the logistic regression model with maximum iterations as 1,000. You can change the number of the maximum iterations, but it is best to ensure convergence. I am taking it here as 1,000 here. You can play around this parameter and obtain the result. We are going to perform the 5-fold cross-validation to evaluate the model. So that means the data set is split into 5 parts and the model is trained and tested 5 times. And after that, we will print the average accuracy across the 5-fold models. So one hot encoding, the accuracy is coming as 0.97. Similarly, for bag of words, we are going to do it. Just we have to select the binary equals to false. It is the code is similar to the one hot encoding one. So the accuracy that we are obtaining here is again 0.79 since we are using a small data set. So the accuracy will be somewhat similar when you are working with a large data set. That time you can see a considerable amount of changes in the accuracy. In the third section, for the TF-IDF, we are going to create a count vectorizer object. Unlike one-hot encoding, this will count that how many types it is going to appear. So converting the clean text into the yep. From here, you can see that it is going to initialize a logistic regression model. Again, I'm taking the max iteration as 1000 and going to perform the 5-fold cross validation. And after printing the accuracy, you can see it is giving 0.95. And for the word to vec section, these above steps are very similar all the time. We are going to train the word to vec model on the tokenized sentences here. So in the word to vec, the parameters that we are passing here, the first is the sentences. So that is the training corpus that we need to operate on. The vector size that we are taking here is 100. So this is the dimension of each word vector. The window size that we are taking here is 5. That is a context window. That means the 5 words before and the 5 words after we will be considering that those words. And the minimum count, that is the threshold, we have kept it as 2. That means we can ignore the word that appears less than 2 times. So now inside a function, we are going to split the document into individual words, then retrieve the vectors for each word that exists in the word to vec vocabulary. If the words does not exist in the vocabulary, it is going to return 0. Otherwise, it will give us a vector of length 100. And for applying, we are going to apply the document vector function to each message here. This converts every SMS into a fixed length numeric vector. After that, we are going to initialize the classification model. If you see here, just for the demonstration purpose, I have intentionally commented out this logistic regression model. If you see, if I use the multinomial naive classifier, it is giving me a value error. And the reason it says that negative values, it cannot be handled by a multinomial naive-Bayes classifier. So whenever you are going to run this, make sure your model, whichever model you are selecting, it will have its own pros and cons. So just go through it. For now, I am going to comment this one to run the cell properly. And we will have the word to vec accuracy as 0.86. In this section, we are going to see some observations. We have seen all the vectors in the above technique. So if we see here the sample bag of words vector, which is a sparse matrix, it is coming up here as 0. But if we see the vectors for the word to vec, it is a dense matrix which also contains the positive as well as negative words. So this way we can see that both the matrices constructed by both different techniques are coming as sparse and dense respectively. We can also demonstrate the semantic similarity between the two words, which is the advantage of word to vec using the function most similar. So here we are seeing the word which is most similar to the word free. So it is based on the word to vec embedding learned during the training. So if you do the final comparison of the summary, you can see in the word one-hot encoding, the vector type that came were binary and the matrix created was sparse. So meaning was lost and the accuracy was good. For the bag of words, the vector type was count. It was creating sparse matrix and again the semantic meaning was lost. Similarly for the TF-IDF, which were giving weightage to the rare words, but the semantic meaning was again lost. For that, the best outcome was of the word to vec. Although the accuracy was very low for the word to vec, this is because it will run good for if you are going with the large document. So if we compare the final accuracies, you can see for the word to vec, it is coming lower in comparison to others, but it will improve automatically when you are going to use the right machine learning model and heavy data set for this. So I hope you have a brief idea about the end-to-end NLP pipeline, which will be same for all the other use cases. So we will conclude this session with an assignment for today. You can go and download any publicly available data set. You can perform the text pre-processing and feature extraction that we have discussed yesterday, and then we can apply different types of text vectorization techniques that we have discussed today, and then we can build a machine learning model for classification and then compare the results for that. You can have some ideas from here. You can perform sentiment analysis, fake news detection, topic classification like sports, politics, technology, and then email category classification. So you will be able to complete all these applications with the help of the same pipeline. And if you have any doubt, you can post it in the chat box, or you can also WhatsApp us. So that's all for today. Thank you for the attention.
Video. Please update the sheets to once the sheet. So I request everyone to please go through the slides and the material that has been shared with you. I'm not getting your question. What do you want to ask? What is to be shared? Dr. Asma, please update the sheets today itself. Please update which sheet you are talking about? Collab sheets. Okay. Yes, we are doing it. What is the random state means here? Can we clarify more? Random state. Random state कहाँ है? क्या बोला है? Okay, answering it quickly. What else? This can be done from any website. Yes, okay. But generally, we advise you to take only the public domain websites and resourceful, the popular ones, authentic websites. Yes. Sharing. Collab sheets, we are sharing. So random state controls the randomness of the data split. When we say train test split divides the data set, it randomly shuffles the data before splitting it. Suppose we have 10 data sets, we have 10 rows in a data set. So it's 1, 2, 3, 4, 5, 6, 7, 10. After reshuffling randomly, it may be 1, 9, 10, 7, anything. This is what we mean, so that there's no biasing on it. Any other question? So we are here. If you have any question, please let us know. We are sharing the sheets on Collab. Can you please suggest what is a good date for the first quiz? Any idea? Monday is good after the class, like around 5:30, half an hour quiz. Marks will be counted actually, so we have to prepare a bit. So although I'm trying to have the questions during the session only so that you understand what is the question and how do we answer it. You may reply on chat the date for the quiz. Monday 5:30 p.m. is okay. Actually, we can do before the class or in the starting, but the question is people may not join at 2. So it is a mandatory quiz. We'll open it for a longer time, but time given to you is 30 minutes. So those who are working, they can join it later at 6 also. We'll start at 5:30. They can join it at 6 also, but it will remain open for you for 30 minutes. So whatever you want to do it, within the 30 minutes, you can do it. And I request everyone to please attempt the quiz. It is mandatory. If you have any doubt, please let me know. We'll announce in the WhatsApp group as well and the Canvas as well.